This video is on parabolas. A parabola is the set of all points in a plane equidistant from a given point, which is the focus, and a given line, which is the directrix. Here's a diagram. A parabola should look familiar. It's basically the shape of a quadratic curve. It has a vertex, and then there's a point inside the bowl called the focus, and then a line outside of the curve, which is called the directrix. So the definition of the parabola says that this distance from any point on the parabola to the directrix, and recall that the distance from a point to a line is perpendicular. So this distance here from the point on the parabola to the directrix is equal to the distance from the same point on the parabola to the focus. You'll also notice that the parabola has an axis of symmetry. If the axis of symmetry is vertical, then the parabola opens either up or down, and the equation of the parabola in standard form is the quantity x minus h squared is equal to 4 times p times the quantity y minus k. If the axis of symmetry is horizontal, in other words, this parabola could be rotated to the left or to the right 90 degrees. If it opens to the right and p is positive, or to the left and p is negative, then its equation in standard form is the quantity y minus k squared is equal to 4p times x minus h. You'll also recall that the parabola is obtained by taking a double cone and intersecting it with a plane that is not parallel to the base and actually intersects the base. So that gives you this orangish shape here of the parabola. The vertex of the parabola is the point HK, and the focus lies on the axis of symmetry and is p units from the vertex. I put absolute value bars around that because p can actually end up being a negative number, and distance, recall, is always positive. The directrix is perpendicular to the axis of symmetry. I believe we saw that in the picture up here. The axis of symmetry being purple and the directrix here being green. And the directrix is also p units from the vertex. So this distance here from focus to vertex is p, and from vertex to directrix, that distance there is also p units. The latus rectum is a segment that goes through the focus that is perpendicular to the axis of symmetry and has its endpoints on the parabola. Its length is the absolute value of 4p units, and it determines the width of the parabola. So this orange segment here is the latus rectum. Notice that it has its endpoints on the parabola, it goes through the focus, and it's perpendicular to the axis of symmetry. The length of the latus rectum is going to tell us how wide or how narrow the parabola is. So let's take a look at a couple examples here. First is to write the equation of the parabola that has a vertex of -1, 2 and a focus of -3, 2. In order to do this, I like to do a little sketch. I'm noticing that my y coordinates are the same, so these 2 points are going to lie on the line y equals 2, which is a horizontal line. So it's going to look something like this. So if my focus is here at the point -3, 2, my vertex would be over here at the point -1, 2, and that means that my parabola, since the focus has to be inside of it, my parabola is going to open something like this. So my axis of symmetry is going to be horizontal, and it's going to be opening to the left. So that means that my value of p is going to be negative, less than 0. So I'm going to use the basic equation, y minus k squared equals 4p times x minus h. And I know that my h is equal to -1. I know that my k is equal to 2. And so I can plug those in. Oh, and then I know, this distance right here between the vertex and the focus is p, and from -3 to 1 is 2 units, so p is equal to 2. So I will have y minus k squared equals 4 times p times x minus a negative 1. And I know that since it's p is going to be negative, so I'm going to put a negative sign there. So cleaning that up, y minus 2 squared is equal to negative 8 times x plus 1. And there's the equation of the parabola in standard form that has a vertex of negative 1, 2 and a focus of negative 3, 2. Take a look at our next example here, which says write the equation x squared minus 4x minus 4y equals 0 in standard form. You'll notice that that's the equation of the parabola in general form. And we want to identify its vertex, focus, the equation of the directrix, and the length of the latus rectum, and then go ahead and graph it. So the first thing I want to do is I'm noticing that I have an x squared but not a y squared, so that tells me that my parabola is going to, my axis of symmetry is going to be vertical, so it's either going to open up or down. Let's go ahead and complete the square here. So x squared minus 4x is equal to, and then let's go ahead and move the 4y to the other side. And completing the square, I'll add 4, and I need to add 4. This factors into x minus 2 squared equals 4y plus 4, but let's go ahead and factor a 4 out of that. So x minus 2 squared equals 4 times y plus 1. Okay, so I'm noticing a couple things. This is going to be, as I said, my axis of symmetry is going to be vertical. It's going to be going up and down. This value here is 4p, so p is greater than 0. So not greater than or equal to, sorry, greater than 0. So this is going to open up. So my parabola is basically going to look like that. H is equal to 2. K is equal to negative 1. So my vertex is going to be the point 2, negative 1. So I think I'm going to go ahead and graph that. 2, negative 1, there's my vertex. Okay. So this value here is 4p, so 4p is equal to 4. So that means p is equal to 1. Recall that p is the distance from the vertex to the focus. Since it opens up, I know my focus is going to be right here. It's also the distance from the vertex to the directrix. And even though it didn't say draw the directrix, I'm going to draw it in here. And that's the line y equals negative 2. So my focus is the point 2, 0. My directrix is the equation, whoops, it's not a point, it's an equation, y equals negative 2. And the length of the latus rectum is 4 times p, or 4 times 1, which is 4. So remember that the latus rectum is a segment that goes through the focus, and the endpoints lie on the parabola. If its length is 4, that means that I'm going to have 1 point over here, 2 units to the right of the focus, 1 point 2 units to the left of the focus. And from there I can draw my parabola through the vertex and through the endpoints of the latus rectum. And there's my parabola. So in this video, we took a look at parabolas, what the equations are in standard form, the fact that they can open up, down, left, or right, how to identify, when it's written in standard form, how to identify the vertex, the focus, the directrix, the length of the latus rectum, and then how to graph a parabola.